Okay, for number 4, we're looking at inequalities. Notice instead of an equal sign, there's a little greater than, there's a greater than or equal, etc. So this is just doing a really quick review to see, do you remember how to solve inequalities? Meaning treat them like an equation, but then there is a couple things we need to remember about the greater than or the less than signs, and then how to graph those. So let's check this out. So same as if this was an equation, we would start here by distributing. So negative 2 times 2x and negative 2 times negative 4. So just distributing that middle part, we're going to still have this 6x here. We're still going to have this entire part here on the right. Next, we're going to combine like terms on either side. So notice that there is a 6x and a negative 4x. All right, now that we combined on the left side, we're able to start moving things around. We want the variables on one side. We want the constants on another. So for example, I could move these x's in this direction by subtracting the x's, leaving negative 2x plus 8, and then I minus the 8. Now, at this point right here, actually, let me write this up here. Negative 2x is greater than 6. So when we divide by a negative, this is kind of the big deal of inequalities. Do you remember what happens when you divide by a negative? This still becomes negative 3 over here, but the greater than is going to flip to a less than. So that's the big golden rule of inequalities that you're supposed to remember. When you divide or multiply by a negative, it flips your sign. So now we're going to go graph this. Imagine you have a 0 and a negative 1, 2, 3. We're going to be putting some sort of a line graph here to show where are all the values that are less than negative 3. So notice that if I want to say less than negative 3, I'm going to need to shade to the left, because negative 4, negative 5, negative 6, all the numbers in that direction. Notice I'm going to represent this with an open dot for a less than. Do you remember that? When it has an equal to bar, that's when we can use a closed dot on the graph, because it's equal to that value, plus it can go in either direction. So for this one here, when we want to say less than negative 3, we're going to do an open dot, and then we're going to shade to the left. So x is less than negative 3. It's going to be open dot at negative 3, and then shade left. And that represents all the values that are less than negative 3. Okay, let's go do the next one. For the next one, we've got this 2/3 times 9 and 2/3 times 12. So I just want to remind you that 2/3 times 9 is like saying top times top, or 18, and bottom times bottom, which is 3. And 18 over 3 is just 6. So 2/3 times 9x is going to give us 6x. Another way that some people see this is they know this shortcut of cross canceling. So you could say 3 goes into 9 3 times, and 3 times 2 is just 6. So either way you do it, whether you do 2/3 where you do top times top, bottom times bottom, or whether you do this cross cancel way, we should yield 6 as the result. So 2/3 times 9x is 6x. 2/3 times 12, same thing. 2/3 times 12. How do you want to do it? Do you want to say 3 goes into 12 4 times? Or, and then 2 times 4 is 8. Or do you want to say top times top, bottom times bottom? So top times top would be 24. Bottom times bottom is 3. 24 divided by 3 is 8. Either way, whichever way you prefer to do, we should yield 8. Okay, so that fraction part's out of the way. Now we can say is greater than or equal to this. And just like the last problem, we're now going to start moving the variables to one side and moving the constants to another. So I'm going to move the x's over to this side again. And then I'm going to move the variable this way. I'm sorry, the constant this way. And then we divide by 3, divide by 3. This time when we divide by 3, because it's just an easy positive 3, we just keep the sign the same, greater than or equal to 4. Okay, so we go graph that. And like we talked about last time, because it's greater than or equal to, this little equal to, this one is going to represent a closed dot on the graph because we want to include the value. We want to say x is greater than or equal to 4. So the fact that it can be equal to 4 means put a closed dot, and then greater than, we shade all the values greater than or equal to that 4. How'd you do? Now part C says, for each of these problems, is there only one solution? Explain. There are many solutions or infinite solutions. Not just one solution. Because the arrow goes forever. So for example, when I get just one answer like x equals 3, that's just one solution. But here, x equals 4, x equals 5, x equals 6, x equals blah, 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 forever. It could be any of those numbers, 4 or greater than 4. And so there are infinite solutions, not just one solution, because that arrow represents going forever.